Hello, in a previous video I spoke about alkenes. Okay, so with alkenes, it's up to you. You might want to pause the video and have a look at what's on the board first. I'm not going to add any extra annotations to this, but what I am going to do is I'm going to talk you through it. So we talked about alkanes, having the general formula CnH2n plus 2. So they've got double the amount of hydrogen that they have carbon plus an extra 2. Alkenes general formula, they've just got double the amount of hydrogen than they've got carbon. Okay, so you're just doubling that amount. They always contain a double bond of carbon, and that's represented with 2 lines rather than 1. If you're interested what a double bond is, when we have a look at non-metal bonding, we talk about covalent bonding, and it means that they share 2 electrons across the bond rather than 1. Key term here, okay, so your key term is that alkenes are unsaturated, and that means that there's not a hydrogen branch coming off every single carbon. They contain 2 fewer hydrogen atoms than alkanes. So alkanes are saturated and alkenes are unsaturated. Let's have a look at what the alkenes look like. Right, you can't have methane. The reason why you can't have CH2 is because no double bond will exist, because you'll only have 1 carbon and that can't bond with itself. So ethene is C2H4, propene is C3H6, butene is C4H8, and pentene is C5H10, and those are the 4 that are on the specification. Of course, in real life, it does keep on going. You've got hexene, etc. The way that I would draw this is I'd draw your carbons out first. So butene, 1, 2, 3, 4 carbons. With the last one, I'd put that double bond symbol and leave hydrogens off that double bonded carbon at the end. So you can see we've got C4H8. Okay, by definition, alkenes have the functional group C double bond C. Okay, so that's what makes it an alkene, okay, as well as the general formula. Right, you might be asked, how would you test to see if something's an alkene? Okay, one mark answer, okay, you add bromine water to it, okay. If you add bromine water to it, bromine water is orange. When you add it to an alkene, it goes colourless, okay. You've got to double underline, you've got to use the word colourless, okay. When I had when you have a beer, okay, the beer, if it's not got sediment in it, is clear, okay. That doesn't mean it's colourless, so don't use the word clear. Make sure you refer to it as colourless, okay. Why does the bromine go from orange? Okay, because it breaks down this double bond inside the alkene. So when you add your bromine to it, then that double bond disappears. You end up with a single bond, and the bromine adheres to the 2 carbons and bonds. Okay, so there you go. Right, alkenes also react with hydrogen, water, and the other halogens. Halogens is your group 7, so that is your iodine, chlorine, fluorine, astatine, and bromine. Okay, you might be asked to talk about the reactions that are related to alkenes. They either behave like the alkanes and they combust completely. So if you burn it with oxygen, then you end up with carbon dioxide and water, okay, like an ordinary fuel. Okay, if you don't supply enough oxygen for the amount of alkene that you've got, so we've got ethene in these 2 examples here, okay, then it's incomplete combustion. So you see we've got 2 lots of ethene moles here, okay, and we've still only got the same amount of oxygen as previous. What it would do is it'd give you particulate carbon in the form of soot, so it'd give you solid carbon floating about. It'd give you carbon monoxide, which is a colourless, poisonous, odourless gas, and you'd end up with water. Now, this is why you end up with a carbon monoxide alarm on your gas boilers, because if you've got incomplete combustion, in other words, not enough oxygen, then it starts producing carbon monoxide, which is dangerous. The giveaway sign that you are not doing complete combustion, in other words, you're doing incomplete combustion, is when it burns in the air, you get a smoky flame instead of a crisp, clear flame. Okay, that is the alkenes. Thank you.